fascinating to go microscopic in soils. But if you take that scale that we've been looking at this morning and then try and translate that to what a farmer might relate to, how do we do that? So a 6-inch ring, say that might be where a corn plant grows in a field. So how many of those rings are there in an acre, more or less? Okay. A typical corn population for irrigated corn might be 30,000 plants per acre. What's an average farm, irrigated farm size in Nebraska now? So 900 to 1,100 acres. The average farm size is around 900 acres. Now, if we're talking about an irrigated farm, it's probably going to be larger than that. But to make it easy, say 1,000 acres. If we're talking about 30,000 times 1,000, all of a sudden we've got, for those math whizzes out here, what's that, 30 million observations that we could take. All of a sudden, it becomes unmanageable, right? We can't go around and measure each one of those corn plant environments to know how each plant is, what it has as an environment. So in terms of crop production, that is something that we really need to be able to scale up for farmers. And it's important for your students to get some idea of scale and variability as it relates to scale as well. The modern survey in Nebraska, I think, was finished in the late 70s. So this printed copy of the county soil survey is something that is no longer being produced, is my understanding. And instead, it's being replaced with what I'll go through here for a brief time anyway on the screen, the web soil survey. But putting soils to work is where you may want to start with in terms of this as a resource. I tend to think, and what we talked about primarily in terms of putting soils to work, is from a crop production perspective, or maybe in a lawn or a garden perspective. What are some other ways that we use soils? Roads? Okay. I was thinking as I was driving up here this morning about construction that's going on about 50 miles to the east of here of levees, and how much maybe some of the basic physical and engineering properties of soils they're needing to be aware of as they construct those levees. That's getting to be a bit far afield from an area that I claim much expertise. But there's information in these county soil surveys that may have some bearing on levee construction, for example. So the majority of the information that we think of and I refer to relates to crop management and those soil properties. But there is information in here on if you want to have sanitary facilities, using it for construction, for foundations, things like that that are important to know. Well, in lieu of having a printed copy of the county soil survey, today we have, in some respects, what is even better. It's still very handy for me to be able to pick up a copy of the county soil survey that's printed in my office, and I have surveys from probably 40 or so counties in the state in my office to be able to refer to in areas that we do research. But the web soil survey, I was going to spend a little time introducing you to, and then maybe we'll stop before we get too far into your lunchtime talking a little bit about nutrient management. So the web soil survey, I've got the site up here, and if you just Google web soil survey, why, you'll find it pretty easy. There are a couple of resources with NRCS now that I use a lot. One is the web soil survey and the other is the spatial data gateway. And both of them they've designed with these big green start buttons. So that makes it pretty easy. You just push the start button and you go to the site that actually begins the survey. So I will just walk you through a process a little bit and not go all the way through, but give you some example of how to use this. And what I would encourage you to think about is how you can use this with students to explore where they live, to learn in detail about their home. It's very easy to find those things now through the survey. They start with this graphical interface with a wide range of ways to locate things. So you can do that. I think they've got 6 or 8 options up listed here. But we'll go ahead and we'll start with state and county. I'll scroll down to Nebraska here. And I will use Clay County since that's where I have spent much of my career and I'm familiar with that. So we'll view that. That's in the south central part of the state. Brings up a graphical map with some roads on it to kind of reference roads and towns to have some idea of where you are. So if I use the cursor then to zoom into part of Clay County here, at some point then it brings up, as you're zooming in, it starts to bring up the aerial imagery to help you identify where you're located. And so this starts to introduce some scale of variability that is of interest already. Is anybody familiar with Clay County? Okay. What are we seeing the corner of here? Okay. This corner right here, we see an abrupt change from green to brown, kind of. And that's the northeast corner of the U.S. Meat Animal Research Center, where much of this 35,000 acres here, which used to be the Naval Ammunition Depot, is now in rangeland rather than irrigated crop production. Now the U.S. Meat Animal Research Center still has 6,000 or 8,000 acres of irrigated land, so you see some of that located around through here. But right in this corner, in the northeast corner of the Meat Animal Research Center, is the University of Nebraska South Central Ag Lab. So I will go ahead and zoom into that. It is a section of land here in Clay County. And so for illustration purposes, we'll say that that is the area that we would like to learn about the soils. So once we've zoomed into the area that we would like to learn, we need to define what they call an area of interest. And there are some buttons that you can use up here to navigate in, but one of them that we need to find here is this. We can either define an area of interest by a rectangle or a polygon, but we'll just go ahead and define it by a rectangle and draw a box more or less around the University Research Center. It shows you in this blue hatched area then what is the area of interest. And that's basically what we want to accomplish in this tab. Now, you'll notice here along the top there are tabs that go along. Instead of having to navigate to a different page, we just go to a different tab. So once we've defined an area of interest, then we click on the tab to create the soil map. So what it's done is overlay the soil series boundaries now on top of this area of interest. And so you can see these boundaries here of different soils as they occur within that area that we'll say is our farm. These are the soils then that fall within that area of interest. If I scroll down here, Mike was talking about a Hastings soil. Much of our research farm there is Hastings or Crete soils, which are representative of a large area of the south central part of the state. But we also have some other soils. So what can you tell me, if you happen to know, what's Butler soil going to, how might that differ from a Hastings soil? Does anybody have any idea? There should be also defined here some Fillmore soil. You can read the descriptions here. So if we look at the Hastings Crete, okay, the Butler doesn't have a description here, but the Fillmore does. So I know on our research farm we have an area of Butler and then Fillmore soil right down in this southeast corner of our research farm. What's the south central part of the state known for, or particularly Clay County? Does anybody have any idea? Clay? Okay, rainwater basins. The rainwater basin area is an area that is well known as a resource for migratory waterfowl. Well, these basins are formed in Butler and Fillmore soils. Why those basins are there, because they are poorly drained. They are depression areas that clays have accumulated in and no longer drain as well as the higher elevation, relatively, Hastings and Crete soils. That starts to be an area that then you maybe want to have some knowledge about if you're farming that farm. Are those poorly drained soils something that I would manage differently from those soils that are well drained, for example? And you've seen the illustration of how water can infiltrate based on some of those properties.